Hello, everyone, and welcome to Modular Milestones. We are so excited to have so many of you here today for our 11th very special community meeting. And today we're going to be taking a moment to reflect on all the progress that we've made together in 2024, to share updates on what's coming next, and of course, to answer your questions. So let's dive right in. So starting with an overview of today's meeting, Chris will kick it off for us with a release update featuring an awesome demo from Brad. And then Chris is going to cover our updated Mojo open source approach. We'll hear from Joe on the Mojo standard library, and you'll hear from me on a few community related updates. Finally, we'll round it out with some Q&A. So without further ado, I'm going to hand it over to Chris.
Amazing. Thank you, Carolyn. Kick things off and talk about the Max 24.6 release. So we've been working on GPU support in Max and Mojo for quite some time. And so we're very excited to share that tomorrow, actually, this will be launching. And so today we want to give you a quick preview of what this looks like and what it means and what you can do with it. So jumping right in, so this is our first GPU release. We've been working on this for quite some time. This is a big deal for us. We're very, very, very excited about this. We also want to do this right. So what does this amount to? Well, there's two major pieces of this. There's the thing formerly known as Max, which is the Max engine. This is the thing that allows you to run AI models really fast. And so what we've done is we've put in a tremendous amount of support up and down the stack, enabling this thing to talk to NVIDIA GPUs and make all those flops go burr. Tomorrow we'll launch the actual release. The release notes are very detailed. And so I'd really encourage you, if you want to nerd out about the technical pieces, to dive into this because there is a lot here. We don't have time to talk about graph compilers and all the fancy stuff that goes into this, but there's a lot of meat here. One of the things I'll say that's very special about this is that all the code that runs on the GPU is written in Mojo. And so this is a really big deal. This is a pretty profound step for the industry, I think, because there's no CUDA code or any other vendor libraries that are used in the Max framework. And so this is a pretty big deal. The second piece, which is brand new for us, is this component called Max Serve. So Max Serve is a full stack LLM solution. We can think of this as in the category of TensorRT LLM or VLLM or SGLang, or there's many other things in this category. And so this is designed for high performance, high throughput serving applications. The focus here is to make it super easy to use. There's a whole bunch of features. For example, you can run it locally on your Mac, not just on a big fancy data center server type thing. And so the portability and the other technology benefits of Max really come together to build a really wonderful solution. We're pretty excited about this. So I'll just give you a quick few highlights. So what we've been focusing on doing in this is in this LLM space, we want to make it really easy to deploy this thing. And so we've seen a bunch of different challenges with existing infrastructure. For example, the 20 gigabyte Docker container and things like this. One of the benefits of building the technology from the bottom up is we can have a very thin, very easy to deploy, very low dependency solution that is really easy to work with and integrates with all the existing industry standards. That provides, for example, an OpenAI compatible API for you to use. Of course, performance is a big deal. So we've set the goal for ourselves to release this thing when we got to parity or better with the existing technologies out there. And so we measure ourselves against technologies like VLLM. And so we're very excited that on A100 class devices, this is meeting and beating the state of the art in the industry, which, by the way, is a pretty high bar. The modular team is a very small team. We've been at this for a few months, but competing with the entire industry on performance on models like Llama 3 and other things like this is actually an extremely big achievement. And I'm very proud of the team. It's pretty amazing what the team's been able to do. We're initially launching support with Ampere class NVIDIA GPUs, but AMD is coming soon. And so we'll be talking about that in January. There's a whole bunch of really cool stuff coming. And so this is our first release, definitely not last. Finally, one of the things that we want to do is we want to iterate quickly with the community. And as part of that, we've been shipping nightly releases. Open secret, you don't have to wait till tomorrow. All the stuff's already in the nightlies. And so you can grab it today and start playing with it. But one of the things we've heard is that it's actually it's kind of difficult to know what's going on in the nightlies because none of the documentation gets updated and it's kind of inaccessible, things like this. And so we're pushing out a nice update for the documentation site tomorrow. And so you can have two views. You can either get the latest stable release or you can get the nightly release. This will make it a much more accessible way to get access to the latest hotness if you're interested in following along. So let's talk about GPU programmability. And so this is our first release where we're adding GPUs to Macs, of course. And so we've been building and designing this thing for years now, really with a focus on enabling a new category of programmability. And so we've been working really hard on this. We've been pushing to get improve a lot of the hypotheses that we had for quite some time and validate those by showing performance and building extensibility, stuff like this. So there's good news and bad news on it. So good news is that we're making something available and you can go hack it up and you can play with it and you can do stuff with it. On the other hand, it's not quite done yet. And so like if it breaks, you get a whole both pieces. And so what we're going to be doing is we're going to be actually really documenting a lot of this stuff well in the next few months, and we'll be polishing it up a little bit more, but we didn't want to wait until we had perfection before we gave access to y'all to play with. And so what I want to do is I want to actually hand it off to Brad Larson, who's going to show you some of this live and actually give you a simple example starting with hello world, but then going to something that shows that Max isn't just an AI thing. You can actually do arbitrary GPU programming with it. So Brad, do you want to take it away?
Yep, absolutely. I'll pull up my VS Code here. All right, great. Yeah. So yeah, thanks. So we have so much exciting stuff like launching in this upcoming 24.6 Max release. And we want you to try out all these capabilities. They'll be fully documented with tutorials and much more. But yeah, we're going to show off something that is not as fully documented, a very early preview of our ability to program custom kernels using Mojo. And so these custom kernels will run on the GPU because we want to give you, as members of the Max community, a glimpse into how Modular leverages Mojo every day to write our optimized kernels for GPUs, CPUs, and more. So I'm going to start with a really basic kind of like hello world example. And I'll state up front, these examples are or will be available on our nightly branch of our Max repository. So you'll be able to try them out yourself. The basic Hello World one is available right now. The more advanced one should be coming in the next nightly release. So what we're going to show off is a really basic kernel that adds 1 to every element in an incoming tensor. The kernel itself is written in Mojo, compiled, then passed to our Python graph API, where we'll go and run it on the accelerator. So what we see here is the actual code for the Mojo kernel itself. Much of this is the scaffolding required to enqueue this as an operation for our graph compiler to use. But the actual core work is done in this element-wise function that is applying like an addition of 1 to every incoming element in the tensor. So all this is defined in Mojo. And you notice nothing's specific to a CPU or GPU here. It just works. And then to use this, we have our Python-based driver or graph API, which lets you build a very simple computational graph. Like this is a very simple version of what we do for our larger AI models, where we have a single operation that's enqueued. So we take in a tensor, we enqueue a custom operation, in this case, this simple little add one operation that takes in a tensor, applies it, gets a tensor back out of it. And then we run that graph on an inference session that I've hard-coded to run on a CUDA-capable GPU. So I've got a CUDA-capable GPU and L4 attached to this instance here that I'm going to run this graph calculation on. Now, I'm also showing off one of our neat aspects of we have transparent interoperability with PyTorch and NumPy tensors. So we have a NumPy array that we've randomized with values. We pass that into our inference session. It automatically gets copied onto the accelerator. We run our graph, and then we explicitly copy the device resident tensor back down to the host to get the values out of this. All of this calculation is going to run via a single command. So I'm going to go do magic run addition, and that will do our Mojo compilation, graph compilation, all of that run it on device. And you can see like we're comparing it versus a local NumPy calculation of the same type, just to verify that the calculation is correct. So all of that ran a custom Mojo kernel on the GPU. And again, we can run this on the CPU by just changing the device. There's no code changes. It runs transparently across all these different devices. So let me show you one more, a little bit more advanced example, and that is calculating the Mandelbrot set in a Mojo kernel on device. And so you can see here, we've got a more complex, pun intended, function that we're running to operate this kernel in parallel on the device. And so it'll calculate the number of iterations to escape in the Mandelbrot set. So again, same graph, same everything. I'm going to do a magic run, Mandelbrot. And there you go. It calculated the Mandelbrot set on GPU using a kernel we defined in Mojo. So again, you'll be able to try out the basic Hello World example is available today in the nightly Max repository. It runs against the nightly version of Max as well as our upcoming 24.6 release. It's available in the examples custom ops directory. Mandelbrot 1 is coming soon. I'll caution that these are very experimental. Like much of this is undocumented. The interface hasn't stabilized and it most likely is subject to change before our next stable release. But we wanted to show like the Max community, like we believe that Mojo is the best way to program GPUs. And this is a preview of that capability for you to take a look at and kick the tires on today. So I'll hand you back to Chris and Caroline to take you through the rest of the neat stuff we're talking about today.
Awesome. Thanks, Brett. Yeah, I mean, this is us trying to be open and share things early instead of waiting for perfection, which we've done before. Yeah, where'd my screen go? Awesome. So if you want to poke around with some of the code, you can go to this modular/custom ops link and you can go browse one of the examples and kind of poke around. There's tons of stuff that you can do. We'd love to see you play with it and either add stuff to the Discord or to the discourse forum if you have questions. The GPU channel will be a great place to go. All right, so there's tons of stuff. 24/6, again, we're just like totally scratching the surface on this stuff. Enterprise deployment feature focus things, there's chatbot enablement things, PyTorch support, there's fancy GPU programming stuff, for example, and there's a ton of stuff across the entire space. Also, Mojo gets a massive update in 24/6, and so there's a bunch of ownership related features and a ton of other stuff. All the changelogs we pushed out tomorrow. It's a big deal. So the team's been working extremely hard on this. I'm very, 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 very excited about this. This is a big step for us. All right. So what's coming next? Well, so this as we like to talk about in the team, this is our first GPU release. So this is itself very exciting, and I'm very, very, very happy to get to this point. We also have a ton of stuff to do going forward. And so I think that this puts us in a really good place to move very rapidly. As we go ahead, just in the next few months, we're going to be launching a whole bunch of new stuff. So we're going to be polishing up the GPU programmability APIs. That means making the graph APIs nicer, making the Mojo GPU programming APIs nicer, publishing more examples, tutorials, like actually polishing this kind of stuff up. We'd love help on that. Like, if you're interested in building tutorials or if you want to build examples or cool stuff like that, please let us know and we'd love to see what you can do. On the model side, the launch includes support for several very popular LLMs and things like this, like Llama, for example, but there's obviously a whole bunch of modalities and other things coming. I can't wait to tell you about other hardware, by the way. Like a lot of our investment in what we're building is really about this generality of hardware and the explosion of new devices that are coming out. So early next year, we'll be talking about other devices that go beyond 8, and that'll be very, very fun. And in the serving category, there's tons of stuff happening. There's more performance. We will be exceeding state of the art, and I'm very excited about that. More features. There's a whole bunch of stuff that will continue to come out. If you're interested in this kind of stuff, I'd really encourage you to look at the Max changelog. There's a whole bunch of detail on this release in the changelog, and it talks through a bunch of stuff you can do today and also kind of some of the things that we'll be working on going forward. One of the things we're planning to do, FYI, and we can talk about this in Q&A, is we're planning to merge the Modular ML, Mojo, and Max repos into one category. And so that'll make it easier for us to roll out all these examples. And so we don't think that's going to cause a big disruption, but that'll make it easier to push things forward, and we'll figure out the details on that. All right, let's talk about Mojo. So Mojo, I know many people are fond of. I am too. Mojo has a big set of exciting features. I'm not going to talk about features, by the way. The changelog is the best place to go, and there's a number of folks that have been actively involved in Discord and the nightlies and all this kind of stuff. So one of the big questions we've had is about messaging. And so if we go back, we launched Mojo about 18 months ago. And one of the things we chose to do is we said, okay, well, Mojo, as it grows up, will become a superset of Python. I still believe this to be true, by the way, but it is definitely not a superset of Python today. And so we've had tons of people that have come to the community, tons of people that ask questions, tons of confusion around this. And so what we've decided to do is just take a step back. And I'm a very vision forward, I can understand what a programming language looks like when it grows up, and it takes a couple of years to do this kind of guy. But I think the world isn't quite ready for that yet. We want people coming into the community that are excited about what Mojo can do today, not just about what it can do tomorrow. People want it, what it can do tomorrow can come tomorrow. That'd be also great. And so what we're doing is we're changing just some of the outbound messaging on this without changing our plan. And so the messaging, well, today Mojo's really good at things like GPUs and performance and SIMD and things like this, right? And so this is where its real strengths are, and it's really growing up, and it's being very great there. And so what you'll see us doing is you'll see us positioning and explaining it as Mojo is a GPU thing, or Mojo is a performance thing. Mojo GPU programming involves both very fast host compute and device compute, and it's the best way to program both CPUs and GPUs. These kinds of messages is what you'll hear us say. We think this is something that is very powerful. Only Mojo can do this. This is a very unique feature, and we think this is a good way to draw in folks that can benefit from what Mojo is useful for today. But of course, over time, what we will do is we will continue developing language, investing in new features, build out things. I expect that, at some point it'll be a very credible language and the capability of Rust, for example, and so that'll be a very exciting thing. It needs some more features, but as it does that, that'll expand its feature set. We'll then add more dynamic features, and as we add more dynamic features, it will feel much more a language in the Python family. Depending on exactly how far we want to go with bug-for-bug compatibility with Python, I do think it will grow into a Python superset over time. Though I think that a Python family language that's 1,000 times faster means you probably don't need to have exact compatibility, and so we'll figure out exactly what we want to do with that over time. And so as we plow through this and we build together over the course of the years ahead, then we can decide to upgrade our messaging and talk about more use cases and go. But we think that being able to solve this heterogeneous compute CPU GPU programming problem is a pretty big deal, and we think it's pretty interesting. And so that's where what we'll be doing is we'll be kind of messaging around that also generality. Next, let's talk about Mojo and open source. So this is something we've gotten lots of questions about, and even going back to the very beginning of when Mojo was first released. So we've told the world that we are very fully committed to open sourcing Mojo. And so earlier this year, it's amazing how fast this year has gone. We open sourced the standard library. And so that's a big deal for us. We're still figuring out how best to work with this. Joe will talk a little bit more about that, but we think that this is a really big deal. And I mean, I think that I'm thrilled to get to work with many of y'all and many of the contributions, but also many of the learnings I've had just interacting with people on this has been very positive, and I'm very excited about this. We do still plan to open source the compiler. We get questions about this all the time, but as from before, we're still bound by this need to build something the right way. And so we want to build the right thing. We don't think design by committee is the right way to go. I personally learned about this from other languages like Swift, where if you get too many people involved too early on, what ends up happening is just everything goes really slow. You spend all your time arguing, and sometimes, particularly early on, you want to just bias towards action and just get stuff done. And so I think this approach is the right thing for us. And really, it's the long goal of how we're looking at things. Another thing that, just FYI, is we plan to open source a lot more things. And so big chunks of Max will be open source as well. And so we think that open source is a really important thing for us to do. And so some of the frustration I've heard is that, okay, Modular's saying it's going to open source Mojo, but when? And the challenge that we have is we can't really tell you exactly when, but we know it's not today because have too much stuff going on and we're still getting on top of the open source community. But on the other hand, we want to give you some commitment so that we're not just messing with you all forever, and we want to give you some kind of a backstop. And so we kind of have been debating this and trying to figure out what we can do. I think that 2026 is the right year. And so we're going to see what we can do, and maybe it'll be earlier, but we as a team are committed to releasing the compiler, and so you can actually build Mojo open source compiler and the standard library, the whole thing, by at least the end of 2026. So it's 22 years from now. And so we might be able to do better, but we can't promise anything. And so we're giving you a firm commitment so you can hold us accountable. And so we can move forward and you can have a little bit more assurance that we're actually going to do this at some point. And so I hope that's useful. But what we're trying to do is we're trying to thread the needle between let this thing grow up and do it the right way and continue to evolve and iterate, but then also make sure that that we're committed to this. And so our goal between both Max and Mojo is we want to give lots of people superpowers. And this is where I think that the whole mission of Modular is to democratize this new kind of compute, enable more people to participate in this. And I feel like today we're in a world where so many people want to learn about, for example, GPU programming, but also all the other ASICs out there. And they want access to it, but just there's so much complexity. This world is just a nightmare of weird tools that don't work together. And if we can make a dent in this problem, I think it'll be a pretty profound step forward for the entire industry. So with that, I want to hand it off to Joe, and Joe will give you an update on the standard library.
Yeah, thanks, Chris. Building on top of some of the things Chris and Caroline have said earlier, as we're reflecting on 2024, next slide, Chris. So we're just reflecting back here, and we have had a lot of contributions. Specifically, we've had quite a diversity of contributors as well. So we've had over 100 contributors between the standard library and docs. And keep in mind that we just open sourced the standard library at the end of March. So we're looking at 8.5, 9 months. And specifically, we've had somewhere between 500 and 1,000 contributions. And it's overwhelming at times, frankly. Like we were definitely over our skis when we shipped the standard library, given the current staffing of the team at the time. I remember one week specifically, I think we had over 80 PRs in 1 week, and I think we got 40 PRs in one weekend. And then they're like, they felt sorry for me coming back on Monday. So we were definitely drowning. And so next slide, please. But first of all, we would just want to say thank you as we're reflecting on 2024. You guys have been a great community. And while we've definitely wished we could support you more quickly, certainly at times, we've done our best. And next slide here, Chris. And so we're very grateful for the community, and we want you to understand that we're a small team, and we appreciate your patience as we've been navigating internal things while also balancing the community contributions and how to build Mojo right, and when it makes sense to do certain things, and when you work around compiler bugs versus building it right and doing it the long term, and how you balance everything. And so we've made a few changes to improve the contributor and community experience, mainly aimed at providing you a level of transparency and guidance on just how much goes on behind the scenes that isn't seen necessarily just on the open source side of things. Next slide. And so there's three big things that are changing. First of all, when we shipped the standard library, we were very eager and we thought that we'd be able to get to everything within 1 week. As I just told you from a previous anecdote, 80 PRs and 1 week turnaround time is quite a lot to ask for a team of just a few engineers. So while we're definitely looking to get to community PRs quickly, we want to give a more accurate upper bound. That way we're not constantly letting you down and feeling like we're not serving you correctly. So we've bumped it up to 3 weeks with consecutive feedback for comments and feedback and that sort of thing happening a few days after that. And then there's a couple of different kinds of community contributions. There's like features, bug fixes, and that sort of thing. Those get to quicker. But then there's other things like bigger proposals, designs, changing the language, that sort of thing. These require some internal team communication, sometimes with the compiler folks. It's not just us on the library. And this can lead to longer review times, especially as we want to give you a more thorough API design review if we want this thing to be hardened and set for the test of time. And so we've bumped the time up there a little bit. And more specifically, as I mentioned, there's a lot of things that go on behind the scenes. Like, given that Modular has open sourced part of the standard library, and we've committed to open sourcing more things in the future, when you change something in the community, you're changing parts of the open source of the standard library. But there's a lot of things that go on inside Modular when we sync your change in and try to build the world. Specifically, we have the biggest Mojo code base out there in the world. There's a lot of things going on, and the compiler is early. And so we frequently hit compiler bugs. I would say maybe 1 in 5 community PRs, 1 in 10 community PRs hit a compiler bug. And depending on how much free time Chris has on his hands to squash the bug quickly, that plays into how quickly those get fixed and how we work around things and that sort of thing. And so we've added a little bit more context and color there for some of the things that go on behind the scenes. Next slide, Chris.
All right.
Thank you so much,
Caroline,
Joe.
do you want to share?
Yeah. So I've got a few exciting community updates, starting with our new forum. So last week we launched the official Modular forum, which lives at forum.modular.com. But don't worry, the Discord server isn't going anywhere. Discord will continue to be a great place to hang out with your fellow community members, have quick chats, and socialize. But we really created a forum to provide a more discoverable, scalable, and accessible place for really technical, extensive troubleshooting threads and for questions that require a response from the Modular team. So if you haven't signed up for the forum yet, please do so. Check it out, introduce yourself, and be sure to share feedback with us on how we can improve this space for our community. Last week, we also launched the early access preview of community packages distributed via Magic. And so we're looking for folks to get involved in this preview by installing packages, submitting your own packages, viewing community submitted packages, and sharing your feedback along the way with us. So you can get started in the forum by following this link on the slide here, or you can just head over to the community packages preview category in the forum. And one final community note is that over the holiday break, starting on Monday, Modular as a company will be mostly shut down for about 2 weeks or so. So responses will be a little bit delayed. And with that, before we open up for Q&A, I really just want to take a moment to thank all of you. This whole community is really at the heart of everything that we do, and your support, your feedback, and your enthusiasm are really what drive us forward. So as we reflect on 2024 and we look forward to next year, we're so grateful to have all of you along with us on this journey. So thank you again, and here's to a great 2025. And now we will open up for Q&A. Starting with Phil.
Hi. First, I want to say thanks to all you guys for all the hard work. So I kind of have maybe 3 questions. Maybe I'll pick 2. So firstly, I'm curious about if you could break down what the compilation process is like for for NVIDIA GPUs. Eventually, it has to be PTX, but what steps does it take to get there? And then the second question is if you have PTX, can you then look at it through something like Insight Compute and see side by side your Mojo and your or I guess SAS that would eventually runs on it?
Yeah, absolutely. So we have full debugger support, full profiler support. So Insight Compute, you can see the SAS. I don't know offhand exactly how much of that is automatic. Walter, I mean, I think you're here. I think it should just work for people. Is there anything that would be not
Can you hear me?
Yep, go for it.
Okay. Could you repeat the question? I spaced out a little bit. I just heard profilers and debuggers.
Yeah, he's asking
no
about
problem.
will Insight and the debugger work for folk?
Yes, it will work. The profiler will work pretty well, except for things that don't use a lot of inline functions. The debugger will work pretty well for functions that are not heavily parameterized. If there are a lot of parameters, then right now you cannot see a lot of variables. That's the current limitation, but that's something that we'll be able to fix next year.
Yeah, I mean, what he means is the debugger will work. It's just that some of the variables won't show up. So, yeah, so we put a ton of energy into making it an actually good GPU development experience. If you want to export PTX, there's various hacks. Sora on the forum was talking about how to get LVMIR out of Mojo, and there's something on the discourse thread on that, and so you can look at that, and the same thing works for PTX, and so we have a bunch of different things like that in there. Is that what you're
And
looking
then,
for?
sorry, yes. And then my first part of the question was
How does it work?
yeah, how does it,
Yeah.
What steps, yeah.
Yeah, okay, well, so I mean, this is something where we could have hours-long tech talks on this. So at a high level, and it depends on where you're coming from. If you're looking at an overly simplified way to think about our stack is you have a Mojo compiler, and then you have MLIR, and then you generate ... And so I'm not going to, I'm gonna resist the urge, but I could nerd out about compiler stuff within just the compiler flow from getting from Mojo through the parameterization system, the instantiation system, all this kind of stuff to PTX. And then we handed PTX off to the NVIDIA driver. The bigger secret sauce, which you take a look at the changelog for Max, by the way, is this integration with the graph compiler. And so the actually really cool thing about our stack is that Max can see into the Mojo kernels that you write, and it can use MLIR. It can use the fact that it can reflect on the IR to do things like specialization, automatic kernel fusion, and a whole bunch of other stuff like this that then really is the Max Mojo hybrid thing coming together, which makes it super powerful and gives you a ton of performance. And so when we talk about all of the code running on GPUs is written in Mojo, we're using the same interfaces that you can use. And so Max comes with matrix multiplications, which are quite fast, and stuff like this out of the box, which is cool. But if you don't like them, you can go replace them and build your own stuff, and then you can go do this. And so we haven't had time to build like let's go supercharge a matrix multiplication tutorial, like start from a trivial matmul and then build up to a faster and faster and faster one, like we did when we initially launched Mojo for CPU. I would love to see somebody build that. I mean, it would be super awesome. There's a bunch of tutorials that exist for CUDA that could be used as inspiration, and I think it would be really, really sweet. So I don't know if that answered your question or if there's like some specific aspect of this.
Yeah, it
you'd like
does.
to-
Like if I wanted to understand more, I'd probably have to invest more time. So that's awesome. Thanks so much.
Yeah. Please check out the Max changelog. We put in a bunch of effort into actually explaining what the heck Max is in that thing, and then over the coming months, as we actually document all the GPU extensibility and the kernel programming APIs and stuff like this, it'll be more clear.
Thank you. You got it. We'll do.
Cool. Did you have a second question, or was that one?
What was my other question? No, that's it. Thanks.
Cool?
Awesome. Any other questions? Going once, going twice. Okay, well, if there are no other questions, and feel free to share questions, of course, in the Discord server or the forum if you think of something after this. But we'll wrap it up. Thank you so much, everyone, for attending, and we're really looking forward to hearing all of your feedback on tomorrow's release. So see you next year.
All right. Well, so to just plus one, Carolyn, thank you, everyone. There's a ton of stuff going on. This is the start of something that I think is going to be pretty cool. We think it's pretty interesting, exciting, but going into next year, you'll see a lot more, even better stuff coming out. We'll be shipping frequently, and we can't wait to work with you and get all the GPUs going burr. So it's a fun time. So thank you all. Happy holidays and take care.